if we make contact with them. I think in this century, we'll probably pick up signals from an extraterrestrial civilization.
If the first known interstellar object passing through our solar system teaches us anything, it's that the interconnectedness of the universe suggests that extraterrestrial worlds share more similarities with our own than previously assumed. The Pan-STARRS telescope in Hawaii detected a faint blur on October 19, 2017, while scanning the sky for potentially hazardous asteroids. The path of this object was completely unprecedented, marking it as the first of its kind to be discovered. Dubbed Oumuamua, this alien visitor took the form of a cigar-shaped object hurtling through space on its end, representing the first asteroid to travel between stars. Oumuamua's peculiar shape, unique from the spherical nature of most objects in our solar system, caught the attention of astronomers. Racing past the Sun at approximately 320,000 kilometers per hour, its flat, elongated structure defied conventional explanation, prompting speculation that it could be from extraterrestrial origin. Renowned physicist Michio Kaku startled the world with his revelation that Oumuamua would make a direct impact in 2 weeks and is believed to be a messenger from another universe. This enigmatic guest raises numerous questions. What do we truly know about its nature? Why is it returning? And why does Michio Kaku suggest it'll make a direct impact, along with the idea that it hails from another universe? Let's delve deeper into the mystery to uncover the answers. You've likely come across the saying, visit the galaxy before the galaxy visits you. In 2017, scientists in Hawaii designated a small reddish cigar-shaped object, Oumuamua, as a herald from the galaxy. Discovered in October, this enigmatic cosmic envoy was hurtling through our solar system at a staggering 40,000 kilometers per hour. The term Oumuamua, which is Hawaiian for scout or messenger, was only visible for a short period. The appearance of this asteroid evoked comparisons to Arthur C. Clarke's novel Rendezvous with Rama, where astronauts encounter an extraterrestrial spacecraft traversing the empty solar system. Alternatively, one might find parallels to the monoliths depicted in 2001, A Space Odyssey, symbols driving human advancement. A global frenzy ensued for telescope time to observe the object following its discovery. Even astronomers from the SETI Institute joined the excitement, initiating a precautionary search for extraterrestrial radio transmissions. Oumuamua bears a resemblance to known asteroids that evoke concerns about potentially threatening Earth and human civilization in terms of color and other attributes. However, what sets this asteroid apart is its peculiar shape. It extends incredibly, possibly measuring 800 yards by 80 yards, making it at least 10 times longer than it is wide. In the past, astronomers hypothesized that ice fragments, occasionally expelled from the rocky disks forming distant planets, would enter the solar system as interstellar debris. These wanderers were expected to appear as comets upon nearing our Sun, vaporizing and emitting light. However, such cometary illumination has never been observed. Astronomers now understand why Oumuamua did not exhibit such behavior. It was only detectable using a powerful telescope with a broad field of view, like Pan-STARRS due to its dim and dark nature. Every 7.3 hours, Oumuamua undergoes dramatic fluctuations in brightness, indicating its rotation around its short axis. This small asteroid's ability to sustain such rapid rotation without disintegration suggests that it's composed of harder, more resilient material than icy debris typically found in comets. Spectral data reveals that Oumuamua exhibits a dark red hue, resembling several moons in the outer solar system whose organic molecules have been altered by cosmic radiation. Dr. Meach also posits that the presence of iron may contribute to its coloration. Currently, the origin and shape of Oumuamua remain unknown. Dr. Meach suggests that it may have been propelled away from its original star by a supernova explosion, or formed through the collision and amalgamation of celestial bodies. The question of its origins remains unresolved. Initially, astronomers were intrigued by the possibility that Oumuamua's trajectory pointed toward Vega, the brightest star in the Lyra constellation, which is known to harbor a debris disk. Calculations suggested that the object could have journeyed from Vega to our solar system over approximately 600,000 years. However, subsequent trajectory adjustments have diminished the likelihood of Vega being the true point of origin. It's believed that Oumuamua encountered a new star system, marking its first encounter since its speed relative to the Sun resembled that of other nearby stars. However, it's not out of the realm of possibility that Oumuamua has been traversing the galaxy for billions of years. When gazing up at the sky, whether stars shine independently or appear solitary, one could imagine that the journeys of this asteroid and similar celestial bodies offer a vastly different perspective of the galaxy. The gold found in wedding bands owes its existence to the collision of neutron stars, just as the oxygen and iron in our blood were forged in a supernova explosion eons ago and light years away. We now comprehend that meteorites propelled by asteroid impact on Mars frequently land on Earth. Notably, credible astronomers have theorized that one of these meteorites might have transported life to Earth, originating from Mars during a time when it was warm and wet. Yet, to uncover our connection to the cosmos, we must delve even deeper into the past and the outer reaches of space. Consider Oumuamua's potential journey spanning hundreds of thousands of years. Though it may seem lengthy on a cosmic scale, it's but a fleeting moment. The Milky Way galaxy boasts an age of 10 billion years. Consequently, Oumuamua, during this extensive time span, could have traversed approximately 20,000 star systems within our galaxy. Though this figure represents only a fraction of the galaxy's vast array of 200 billion stars, it still amounts to a notable accumulation of experiences on its cosmic journey. As a consequence of Oumuamua's passage, dust and debris from its travels have intermingled among the stars and planets within the galaxy. This occurrence hints at the possibility that the universe may be smaller than previously assumed. Despite Oumuamua no longer being visible, it remains within the vicinity of the solar system. Elon Musk and other astronomers anticipate Oumuamua's passage into the Kuiper Belt around 2024, with an edge transit expected by late 2025. Particularly, Michio Kaku estimates a close encounter with the Voyager's farthest point in 2038. While projections indicate the expansion of our Oort cloud beyond 100,000 AU by 2196, it will once again retreat to a distance of 1,000 AU from the Sun. As a result, depending on how one defines the edge of the solar system, it becomes possible to pinpoint when Oumuamua truly crosses it. Nonetheless, due to astronomers' inability to reach Oumuamua, they're currently maximizing the limited information obtained over just a few months to comprehend as much as possible about this peculiar interstellar visitor. Initially mistaken for an asteroid due to its size, approximately 2,600 feet long and 260 feet wide, Oumuamua's behavior puzzled astronomers and scientists. Instead of following the expected trajectory, it exhibited significant non-gravitational acceleration, suggesting the influence of forces beyond gravity in dictating its motion. Meach suggests that various factors could lead to acceleration in that direction. Her team explored at least 6 potential causes of acceleration, but several were dismissed during the investigation. Some were deemed implausible because they required an object to possess extreme characteristics, such as being less dense than aerogel. Others were rejected because the acceleration they produced did not align with observed data. After careful analysis, the scientists concluded that comet outgassing was the most plausible explanation, as it's a common occurrence in comets. When a comet approaches the Sun and heats up, the surface ices sublimate directly from solid to gas in a process known as outgassing. As gas escapes, it imparts an additional push to the comet, deviating from gravitational influences and altering its speed and rotation. This extra push results in the comet rotating and moving in a different direction. Meach explains that Oumuamua's motion was comparable to that of comets in terms of power, hence it did not appear unusual. She suggests that the absence of dust emissions from the object was notable. Typically, the stronger a comet's outgassing, the larger the grains of dust it can release. When gas escapes from a comet, it often carries surface dust along with it. However, Meach contends that even if the comet lacked microscopic material, significant dust could have been emanating from its surface, affecting its velocity. This notion sustained interest in the comet. Moreover, scientists primarily studied visible wavelengths, where detecting large dust particles is challenging. Hence, the absence of observed dust emanating from Oumuamua. However, what about the gas emissions? Surprisingly, there was no evidence of gas either. Astronomers expected a considerable amount of gas to be emitted, impacting Oumuamua's velocity as observed. Michio's team specifically searched for CN gas, which is known for its brightness and ease of identification. She explains that CN can serve as a proxy for water, which is more difficult to detect, as CN is typically released alongside water from comets in our solar system. However, their detection limit revealed no CN gas whatsoever. Considering that comets in our solar system often contain substantial amounts of water, the absence of CN gas suggests that the comet was chemically exceptional. If such a large quantity of water were to emanate, it would likely originate from a different solar system, which, according to Mich, might not be as surprising. What else contributes to Oumuamua's peculiarity? Astronomers utilized the Spitzer Space Telescope to observe Oumuamua in the infrared spectrum for over 30 hours, attempting to unravel its mysteries, as per Mich. Focusing on the thermal infrared, which detects heat, they encountered a surprising outcome: nothing. However, even non-detections can sometimes provide valuable insights. From this, they inferred that Oumuamua must be brighter than expected if it displays comet-like thermal characteristics. By measuring an object's reflectivity, or how much light it reflects, astronomers can glean information about its shape, size, and composition. Mich elaborates, "We always assumed the reflectivity was comet-like and very low, yet they found a higher reflectivity of around 10%, contrasting with the typical 4% reflectance associated with comets. This discrepancy challenges the notion of Oumuamua being a typical cometary body. Mich suggests that if Oumuamua possesses vastly different thermal properties on its surface compared to other comets, the only way to reconcile this with a 4% reflectivity is by making that assumption. Once again, it presents an intriguing anomaly in the study of Oumuamua. Moreover, the infrared studies did not detect any carbon monoxide or carbon dioxide outgassing from Oumuamua. This finding holds significance, as Michio's team had previously entertained the possibility that the object might be emitting these gases at levels significantly higher than what was observed, due to the limitations of the Spitzer observations. Considering that Oumuamua originated from a different solar system, it's conceivable that these peculiarities are common among objects originating from elsewhere. Corinne Baylor-Jones of the Max Planck Institute for Astronomy in Heidelberg, Germany, traced Oumuamua's trajectory back to before it entered our solar system. Jones then compared this trajectory to the past positions of 7 million stars tracked by the Gaia spacecraft. To identify potential origins, Jones had to rewind the orbits of both Oumuamua and the stars in the galaxy to search for overlapping points. Oumuamua's path intersected with 4 potential contenders, suggesting they could be its former inhabitants. However, the encounter velocities for these possibilities were relatively high, ranging from around 6 to 16 miles per second, posing the primary drawback. Oumuamua is most likely a planetesimal or building block expelled during planetary formation, and it's uncommon for planetesimals to attain such high ejection velocities solely from interactions with large planets. Only a few miles per second would have been our initial prediction, which are high velocities. However, while not entirely impossible, such speeds are quite unlikely. If Oumuamua originated in a binary star system, this scenario would be more plausible. However, none of the 4 contenders were confirmed to be binary stars. Naturally, upcoming Gaia data releases could prove invaluable in aiding astronomers in identifying a more suitable candidate for Oumuamua's origin by allowing them to backtrack the motions of neighboring stars. In a few years, it would be fascinating to revisit this topic. Oumuamua remains the first, and thus far only, extraterrestrial visitor observed zipping through our solar system. Despite the limited data available, experts worldwide continue to be intrigued by what mysteries it may conceal. Undoubtedly, it's an intriguing object with distinct characteristics, sparking assertions that it might be of extraterrestrial origin. A draft article, authored by a Harvard scientist and the head of the Pentagon's UFO office, has proposed the intriguing possibility of an extraterrestrial mothership present in our solar system. This hypothetical mothership is speculated to be dispatching microscopic probes, likened to dandelion seeds, to survey the planets within the solar system. Could it be that a mothership from another world is orbiting our solar system, deploying minuscule probes to investigate its celestial neighbors? Both a Pentagon official and a Harvard scientist entertain the notion as plausible. In their draft study, The two individuals suggest that it's within the realm of possibility for an extraterrestrial spacecraft to be conducting reconnaissance in our galaxy's vicinity, using these dandelion seed-like spacecraft. These tiny probes are envisioned as capable of collecting data and transmitting it back, akin to the manner in which humans launch spacecraft to explore distant planets. They suggest that the document was unveiled by Sean M. Kirkpatrick, the director of the Pentagon's All-Domain Anomaly Resolution Office, established in July 2022 by the Department of Defense to identify and investigate objects of interest, along with Avi Loeb, an astronomer at Harvard University. This collaboration with the DoD produced the document, although it's not an official Pentagon release. Avi Loeb is renowned for his research on Oumuamua and has even proposed the idea that Oumuamua could be an extraterrestrial spacecraft. Approximately 6 months prior to Oumuamua's close encounter with Earth, a small interstellar meteor, measuring about 3 feet in diameter, collided with Earth. Although unrelated to Oumuamua, this meteor, referred to as IM-2, captured Loeb's attention. Loeb entertained the idea that an artificial interstellar object could serve as a parent craft, releasing numerous small probes during its close encounter with Earth, functioning similarly to NASA missions. These probes, likened to dandelion seeds, might be separated from the parent craft by the tidal gravitational force of the Sun, or through some form of propulsion. In their examination of unidentified anomalous phenomena, which is the government's preferred term for UFOs, Loeb and Kirkpatrick adhered to principles of accepted physics in their preliminary study. Given their potentially diminutive size, the scientists speculated that these dandelion seed probes might not reflect enough sunlight to be detected by survey telescopes. They proposed that these probes could journey to Earth unnoticed by astronomers. The researchers hypothesized that these probes could decelerate in Earth's atmosphere to avoid burning up, and then pursue their objectives upon landing, particularly if equipped with a large surface-to-mass ratio akin to a parachute. Scientists speculate that aliens would likely have an interest in studying rocky planets within the solar system that possess atmospheres. Venus, Earth, and Mars would all present enticing targets from a distance, with Earth garnering the most attention, especially after indications of liquid water were discovered. There would be no necessity for the mothership to harbor the advanced extraterrestrial civilization responsible for constructing the probes. Moreover, it's doubtful that the mothership could even communicate with the probes. Prior to the emergence of life on Earth, a habitable planet with intelligent inhabitants may have been dispatching probes. Loeb analogized the scenario to checking one's mailbox for any accumulated packages over time, even if the senders have long ceased to exist. Since Loeb initially proposed that Oumuamua was an alien spacecraft, he's faced criticism from the scientific community. According to some perspectives, the hypothesis that Oumuamua was deliberately sent to Earth was considered both provocative and unfounded. In 2021, a letter published in the journal Astronomy and Astrophysics challenged the notion that interstellar travel would be feasible, citing the significant cosmological timescales required to traverse between stars. The letter concluded that it was improbable that Oumuamua was dispatched by an extraterrestrial civilization, suggesting instead that it was likely just an unusually shaped rock that had randomly entered the solar system. Furthermore, another analysis debunked the theory of Oumuamua being an alien spacecraft by attributing its peculiar movements to hydrogen off-gassing on March 22, 2023. Despite these findings, the Pentagon has recently showed renewed interest in investigating unidentified flying objects observed in American airspace over the past year. More than 360 additional investigations into reported UAP encounters by U.S. military personnel have been initiated by the Arrow since its establishment last summer. Approximately half of these cases have been explained as balloons or balloon-like objects, while for the other half, insufficient information exists to reach a definitive conclusion. Nevertheless, researchers are optimistic that telescopic scans could uncover further extraterrestrial objects, enabling them and other researchers to conduct additional testing of their hypotheses. If the abundance of exoplanets is any indication, this aspiration is not far-fetched. Just 2 decades ago, the discovery of the first exoplanets marked a significant milestone. Presently, more than 4,500 of these celestial bodies have been confirmed. In approximately a decade, data on the types of objects traversing the solar system should become available, providing valuable insights into other solar and stellar systems. As our understanding of the cosmos deepens, so does our curiosity about the possibility of extraterrestrial life. The notion of an alien mothership lurking in our solar system, deploying miniature probes to study distant planets, adds another layer of intrigue to our exploration of the unknown. The draft study by a Harvard scientist and a Pentagon official paints a picture of a vast universe teeming with potential surprises. The idea that an advanced civilization may be observing us from afar, using technology beyond our current comprehension, sparks both excitement and apprehension. However, skepticism from the scientific community is understandable. The concept of Oumuamua, the interstellar object that sparked Loeb's theories, being an alien spacecraft, stretches the bounds of credulity for many researchers. Yet the possibility cannot be dismissed outright, as our understanding of the cosmos is still in its infancy. The debate surrounding the origins of Oumuamua highlights the complexities of studying phenomena beyond our immediate reach. While some argue that natural explanations suffice to explain its peculiarities, others advocate for a more open-minded approach, considering the vastness of the universe and the potential for unknown phenomena. In recent years, interest in unidentified aerial phenomena has surged, prompting governments and scientific institutions to take a closer look at the skies above. The establishment of organizations like the Pentagon's All-Domain Anomaly Resolution Office reflects a growing recognition of the need to investigate anomalous sightings with rigor and objectivity. The search for extraterrestrial intelligence has long captured the imagination of scientists and enthusiasts alike. From radio telescopes scanning the cosmos for signals to spacecraft exploring distant worlds, humanity's quest to uncover signs of life beyond Earth continues unabated. Advancements in technology have enabled us to peer deeper into the universe than ever before. From exoplanet discoveries to the detection of gravitational waves, each new revelation expands our understanding of the cosmos and raises tantalizing questions about our place within it. The prospect of encountering intelligent life beyond our planet forces us to confront existential questions about our own existence. Are we alone in the universe, or are there other civilizations out there, gazing up at the stars with the same sense of wonder and curiosity? The search for answers drives scientists to push the boundaries of knowledge, exploring the farthest reaches of space in search of clues to our cosmic origins. Whether we ultimately find evidence of extraterrestrial life remains to be seen, but the quest itself is a testament to humanity's insatiable curiosity and thirst for discovery. As we continue to unravel the mysteries of the universe, we must approach the search for extraterrestrial life with humility and open-mindedness. The cosmos is vast and full of surprises, and the truth may be stranger than we can imagine. In the meantime, as telescopes scan the skies and spacecraft venture into the unknown, we can only marvel at the wonders of the universe and wonder what secrets lie waiting to be discovered. The search for extraterrestrial life is a journey that transcends borders and unites humanity in a shared quest for knowledge and understanding. In the words of Carl Sagan, the universe is a pretty big place. If it's just us, seems like an awful waste of space. As we gaze up at the stars and contemplate the vastness of the cosmos, let us remember that we are but one small part of a grand and mysterious universe, waiting to be explored. Thank you for watching another video. If you enjoyed it, please give us a thumbs up and stay tuned for more content like this.